One other thing that can cause bad measurements is if after you capture the measurement and move the laser, let's suppose you capture the measurement, you wait for the light to come back on and you move it. Let's do the wrong thing. Let's tap this and move it at the same time. That's bad. What happens is that the laser it has to capture the measurement on a move. It takes 30 points, 50 points rather, in a third of a second. It could give you a bad measurement. So always wait until after the light comes back on and the beep goes off and move the laser like that. Now we're going to talk a little bit about how reflection can cause a bad measurement. Knowing this will help you eliminate it in the future. Okay, first of all, if I put one point here and my second point was over here, let's say it moved close to the corner. Notice this reflection there. Now if we just leave this there, what I'm going to tell you here is that the angle of the encoder goes here. The laser could possibly pick up a reflection here and come back, which adds to the distance of this measurement, which would effectively move this wall this way and cause your back wall to be a longer dimension. This is somewhat difficult to figure out in the beginning, but once you understand it, you'd want to move the laser back about here so you don't have any reflection, especially on a square corner. Now, if this was a drywall corner, we had mud in it, and we were hitting points along here, we would now want to put one right in the corner there, and then out here about 3 inches, and then along the wall. That's how to avoid bad measurement through reflection. Okay, I'd like to point out here that this dot that you see here is about a 10-degree angle shot this direction here to this cabinet base. Now I'm going to move the laser over here, and you're going to see that that dot becomes a long line. This is about as big as you want to see it get. Now, you'll notice here when I move the laser over at this angle how long the dot becomes. Now you can imagine here, if we're trying to hold less than a 1/16 of an inch, I have a dot here that's almost 3/4 of an inch long. Very simply, you just don't shoot anything under 10 degrees. If you do, we have a pin target, and that we're going to show you next. Whenever we have a bad angle, for example in this case, we left the laser at about a 2-degree angle to this edge here. So what we do is we use this pin target. It has a very narrow, just the width of the beam, flat area with a pivot. So we set this up against the base countertop here and rotate it towards the laser. So when we hit this, it indicates exactly where the point is on the edge of the countertop. Then the next thing we will do is hit another one back here on this point, allowing us at any angle to hit a perfectly straight line without any measurement issues. We've talked about the pin target, which allows you to capture measurements from any angle whatsoever. Even in cases, for example, where you would be up against a full height cabinet base here, and the angle was terrible, we could put this up against a full height cabinet base, and then the laser would hit this. Actually, it would look more like that. Now, this is exactly 1/2 of an inch from the full height base. These two pin targets could be offset 1/2 inch to get an exact replica of what that would be without hitting this because of the bad angle. Otherwise, our next most useful target is the clamp target. This was designed to both fit on a new construction cabinet base. It has a convenient 0 slot here. It matches up with the 0 there. If you clamp this on the base unit, this is the edge here or there. Okay? You could use this to do an offset of, let's say, 1.5 inches out from the base unit and hit that. Next, if the laser was over here and I could not see this edge, what I would do then, I would measure to see if my overhang is the same here and here. I have two choices. I could either put one target here and one target here and use that if the overhang is correct, or just taking a tape measure, and this could go all the way up to 8 or 10 or 12 inches on an overhang. Simply use your finger and your thumb to create a point that the target would be placed on that would match the base unit underneath. Two placements like this, and now the laser can hit these two targets and replicate exactly where the base unit is below. I hope you had fun watching the video and you learned a lot, and we're always available for Service and support, probably one of the best service and support machines in the world. 9 to 5 Chicago time throughout the week. You'll see us at some 38 trade shows and seminars and across the country every year. It's a well-supported product. Our people know what they're doing. They've all got experience in the industry, and I hope you enjoy your new LT55XL.